Welcome to the Math Record. Today I'll be covering the ICTM Regional 2015 Division A Geometry. Okay, let's get started. Number 1. Mn is equal to 105 in the diagram shown. Determine the value of k. So we know MP is 4k and Pn is k, so just add them together, so that's 5k is equal to the line length, which is 105. So k is equal to 21. So the value of k is just 21. It's basically just that simple. Okay, number 2. Circle O has radius 7 and circle P has radius 3 and lies entirely in the circle of O. Determine the ratio of the area interior of circle O, but in interior of circle O, but not in the interior of P. So we have O, this is circle O, and then circle P is here. So we want to find the ratio of this entire area, so to the entire circle. So basically, the radius of the O is 7 times 7, because pi radius squared, so that's 49 pi. So pi 7 squared. And then the area of P is pi 3 squared, which is 9 pi. So subtracting together, that is 40 pi all over the entire area, which is 49 pi. So the ratio is 40 over 49. And that's your answer. Basically just that simple. Okay, number 3. A triangle with side lengths extended is shown, but not necessary to scale on this side, right? So as length measures ABC is in the ratio 5, 7, and 8. Determine the ratio of x, y, z. So x, y, z are the exteriors. So the trick to this is that you're going to add the angles that are opposite of what you're looking at. So what I mean is that if A is the 5, right? A is with the x. So then the x is the 1 with not the A, so it's gonna be with the 1 with B and C. So B and C is the 7 and the 8, so add that together, that's 15. Okay, the Y. The Y is with the B, so don't put the B in, so you have to add the A and the C, so that's 5 plus 8 is 13. Okay, the Z. The Z is gonna be not with the C, is with the C, so you cannot use C, so you add the A and the B, so that's 5 plus 7 is 12. Okay, so that's your ratio from X, Y, Z. 15, 13, 12. And that's basically it. So that's just a general property that you could just know. Okay, number 4. A trapezoid with legs of length 8 and 7 and the height of 6 has a numerical perimeter 40. Determine the area of this trapezoid. So we have a trapezoid, okay, with legs of length 8 and 7. Let's say this is 8 and this is 7, and has a height of 6. So this is 6, right? Height of 6. Draw a right triangle, height of 6. And has a numerical perimeter of 40, right? So let's say this entire length plus this entire length plus this 8 and plus this 7, that's equal to 40. Okay, so we know that this, right? Let's call this x and let's call this y. So we know that x plus y plus the 8 plus 7, which is 15, is equal to 40. So x plus y is equal to 25. So the area of a trapezoid is x plus y, parentheses, times the height, our height is 6, divided by 2. Okay, so our area is just 3 times x plus y in parentheses. Our x plus y is 25, right? So our area is just 3 times 25, which is 75. And that's basically it. The 8 and 7 are kind of extraneous information. We kind of don't need it. Okay, so the answer for number 4 is 75. Number 5, Katie jogged 3 miles due north and then 2 miles. Okay, so I usually like to draw a general path. So then Katie went 3 miles north, then 2 miles east, right? So 2 east, and then 4 miles due north, so 4 more north, and then 13 miles due east, so 13 miles due east, and then 1 mile due north. Okay, so determine the Katie's exact direct distance now from the starting point in miles. So from here to here, what's the distance? Well, you kind of could just move everything down. So it kind of looks like, right? So if I kind of redraw that again, move the 2 down here, move the 13 down here. So that's a total length of 15. Now move the 3 over. So there's a 3 here. And then move the 4, and then move the 1. So that's 3 plus 4 plus 1. That is a total of 8. Okay. So basically the same distance. So it's just going to use the Pythagorean theorem. So 15 squared plus 8 squared, and that should give you your answer. So 15 squared plus 8 squared, I think this is 17, I believe. Yes, 17 is one of the Pythagorean triples. So the ones that you want to know is 3, 4, 5, 5, 12, 13. This one's kind of rare, but you could say 8, 8, 15. Okay, what do I write 7? 8, 15, 17. Those are usually the most common three. And 820, and I believe 724, 25. I think that is a Pythagorean triple. I could check. Yeah. And also 724, 25. I've seen this used sometimes. Okay. So number 5 was 17. Okay, number 6. Points points A, D, and C lie on circle O with diameter CD, and AB is 5. Wait, AB is perpendicular to CD at AB, right? With AB is equal to 5 and AC is 13. So determine the length and diameter of the circle. So let's kind of draw this out. Draw something like this, perpendicular, and then right here. Okay, so this is 5 and 13. So I brought this out in the previous question. So you had to know the Pythagorean triple 5, 12, 13, right? So if this is 5 and this 13, that means this entire thing right here is 12. So we know that is 12. Okay. Or you could just use the theorem. Pythagorean theorem. So 13 squared minus 5 squared. Square root, that gets us 12 for the length of BC. So, right? So, now you need to know how to do inscribed angles and lines. So basically, we don't know what this is, so let's call this X. So inscribed angle and lines tells us that opposite lines multiplied together, if they're in a straight line, they should and it's inscribed in a circle, then it's gonna has the product has to be the same. So that tells us if this is 5, then if you draw another line down perpendicular to that line, this is also 5, right? Because it's basically symmetry, right? So x times so this length x, the length of dB is x, right? So let's label this dB, and let's call this C. This is C again. This is A. Okay. So this is just another random point that we just put in. So dB x times BC, which is 12, is equal to A to B, which is 5, times B to that point that we just made, which is 5. So so that's 12x is equal to 25. So x is 25 over 12. So that's the length of x, 25 over 12. So we want to find the length of the diameter of the circle. So it's 25 over 12, right? X plus that 12, because we want the entire thing. 12 times 12 is 144, plus that 25 over that 12, right? Which we're just simplifying. So 169 over 12. And that's your answer. 169 over 12. I'll just write it more clear up here. That's your answer. Okay. Kind of simple. If you know inscribed angles and lines, it should be really simple. Okay. A line KW is a chord of O. KW is equal to 1024 and OK is equal to 600. Determine the exact distance from O to K to chord KW. Okay. So we have a circle and it's called circle O, so the center is at O. KW is a chord, and this is K, this is W, right? And the chord is length 1024. And OK, so O to K, right? That's length is 600. Okay. Determine the exact distance from O to chord KW. So you kind of draw a line, the smallest distance, right? That's the exact distance. So if you kind of cut it, the properties about inscribed lines right in there is that if you kind of cut it, draw right it, the diagram is kind of bad, is that you cut it right in half. So this point, K and then W, right? This line is equal to this line. So since the entire length is 1024, that means half of it is 512, right? So now we could just make that triangle. Okay. So this one's 512 and this is 600. So we just need to find this distance right here, which we'll call x. So you can just use the Pythagorean theorem, x squared plus 512 squared is equal to 600 squared. So let's find x. So 600 squared, using our calculator, 600 squared minus 512 squared, and then take the square root. Okay, so that's a decimal, so we kind of have to find the exact value. So, 600 squared minus 512 squared is should equal in your calculator, x squared should equal 97856. Okay, and that is the same thing as saying 2 to the power 6 times 11 times 139. Even though you use your calculator, you should just factor it. So that means x is equal to 2 to the power 3, which is 8, square root 11 times 139, which is 1529. And that should be your exact distance for number 7. 8 times square root 1529. Okay, so now let's work on number 8. ICTM, okay, is a square with numerical perimeter 40 in a semicircle. IAM constructed with IM as a diameter, and AI is equal to half of IM, and the exact numerical area of pentagon ICTMA can be reduced in simplified form here. Okay, so we want to find the area of that pentagon. Okay, so let's kind of draw that out again. Something like this. Then they do something like this-ish. Okay. So since we know that this is a square and its perimeter of 40, that means 40 divided by 4 should equal the side length. So 40 divided by 4 is 10. So this side length is 10, this side length is 10, this side length is 10, and this side length is 10. So we know IM is 10. That means AI, since one half of IM is AI, that means AI is 5. Okay. So we know that this is 5. So if you have a circle, like this is just a semicircle, right? But if you have a circle and you kind of draw that out, so this diameter is 10, right? So this is 5. If you draw a diameter and you make it inscribe a circle, like inscribe angles and lines, this is one of their properties. If you draw halfway, the angle of this is going to be a 90 degrees. So this is a right triangle. So this is for sure going to be a right triangle. So let's kind of delete this because I was just trying to prove a point. So if we know that it's a right triangle, we could use the Pythagorean theorem. But instead of doing that, this is one of the more main concepts that you should know. If we have a side length x and we have a 30 degrees, 60 degrees, opposite of the 30 is x over 2. Opposite of the 60 is x times square root 3 over 2. Okay, so we see a 5 here. So 5 divided by 2 is, 10 divided by 2 is 5, right? So x, which is 10, 10 divided by 2 is 5. So we know that opposite of of that angle is going to be a 30. So opposite of that 5 is going to be a 30. And opposite of this is going to be 60. So we got to multiply 10 by square root 3 over 2. So that's just 5 square root 3 for this side length. Okay, so instead of like doing the Pythagorean theorem, we would just know this, and you could just divide that by 2 and then multiply by square root 3. Don't simplify, so you want to find the exact answer. So the area of a square is just its side length squared, so 10 times 10 is 100, so that area is square. Area of of this triangle is the base times height, so 5 square root 3 times a 5, and then divide by 2. Right? So that's equal to 100 plus 25 square root 3 divided by 2. Now you want to make everything in the numerator. 100 times 2 is 200. So 200 25 square root 3 divided by 2. Right? And now you need to find the sum. So k is equal to 200, w is equal to 25, p is equal to 3, and q is equal to 2. So add that all together. So that's 5, that's 30, and that's 230. So your answer for number 8 is 230. And that's basically it. Okay. Number 9. A circle has circumference 37.64 and has a radius of k plus 1. Determine the value of k. So the circumference of a circle is always 2 pi times radius. So 2 pi, our radius is k plus 1, is equal to our circumference, right? I mean, our area, our circumference. So our circumference is 37.64. So k is equal to 37.64. Oops, sorry. Uh, is equal to 37.64 divided by 2 pi. Sorry that I write pi's like that. I kind of just write 3/4 of like a box. So 2 pi divided by 2 pi and then minus a 1. Okay, so using your calculator, 31.64 divided by 2 divided by pi minus 1. And it says your decimal to correct a decimal correct to 4 significant figures. So it's 4.991. And that's your answer. Okay. Number 10. Determine all ordered pairs of positive integers r, h, for r is the radius and h is the height of a cone, whose numerical volume is equal to its numerical surface area. So a volume of a cone is 1/3 pi radius the square times height. And the surface area of a cone is 6, actually, sorry, of a cone is, actually, sorry, is pi radius squared plus pi radius times its height. Oh, wait, sorry. Times its slant height, I believe. So, um, we know that our, we could just plug everything in because we know that's equal. So 1/3 pi radius squared times height equal to pi radius squared plus pi radius slant height. So slant height is equal to the square root of radius squared plus h squared. So we could like cancel out the radius and the pi, one radius and one pi. So that's pi a radius times height. So cancel out the pi and radius, so there's only one radius left. Pi and the radius, so the square root radius squared plus h squared. Okay, so we know this is true. Let's kind of delete all this. Oops, and oops, okay. So we have this. Now we could 1/3 radius h minus radius is square root radius squared plus h squared, right? So then we could square both sides, so that's 1/3. I mean 1/9 radius squared h squared minus 2/3 radius squared times h plus radius squared is equal to radius squared plus h squared, right? So we could cancel out these two radius squared. And we distribute out the radius and a 3 out 1/3. So 1/3 radius squared h, right? So that's 1/3, that's h. And then this one is a minus 2. Minus 2 is equal to h squared, right? Well, we could divide h from both sides actually, right? Because there's h squared, h, and h squared. So that's 1/9 r squared h minus 2/3 r squared is equal to h. Okay, so let's kind of distribute r squared out. Well, 1/3 r squared. And that should get us a 1/3 r, 1/3 h minus a 2 is equal to h. Delete. Boot this up. Okay. So that means 1/3 radius squared is equal to h divided by 1/3 h minus 2. So we multiply the top and bottom by 3. 1/3 r squared is equal to, well, we can multiply, yeah, so this is 3h over h minus 6. So it looks a little nicer. And then we can multiply both sides by 3. So r squared equal 9h over h minus 6. So we know that is true. Okay, so we've done all this so we can just find the relationship between r and h. So what numbers can we plug in such that both of them are going to be integers, right? Positive integers. So we had to plug in bigger than, so h has to be bigger than 7. So let's say h is equal to 7, right? So 9 times 7 is equal to 63. You cannot take a square root of 63. So h 7 minus 1, 6. So this was over 1. So you can't take a square root of that. Okay, so 7 doesn't work. Let's do 8. 9 times 8 over 8 minus 6 is 2. So that's 9 times um, 4, which is equal to 36. So radius is 6. Okay, because it has to be positive. So 8, when radius is 6, height is equal to 8 because we plug in 8. Right, so remember that h goes here and radius goes here. Okay, so you know that works. So now we gotta plug in, let's say we plug in 9, right? So 9 times 9. 9 minus 6 is 3. So that's 9 times 3 because 9 divided by 3 is 3. So that's 27. So 27 does not work. Okay, because it's not a perfect square. Now let's use 10. So 9 times 10 divided by 4. This is obviously not gonna work because there's no 5. So it's 5 divided by 2 is 5, divided by 2 is 2. So that's 45 over 2, which is not a perfect square. Okay, so let's use 11. So that's 99. 11 minus 6 is 5. That's not be a perfect square. And then usually you're just gonna like spam your calculator, but all you're gonna do is that you keep spamming your calculator to find the answers. The only answer that you're gonna find that kind of works for 10 is gonna be this coordinate. This is the only one that works. But if you want to keep checking, then that's basically it. But just only 6, 8. Okay, sorry. Number 11. A piece broke off a rectangular ABDF, leaving trapezoid A ACDF, where BD is 16, BF is okay, so let's kind of draw this out because getting confused. So draw a piece broke off right here, then we draw one like right here. Okay, and we know BD is equal to 16, so this entire length is 16. Our BC is 7, all right? So we know that this is 7, the entire length is 16, so this one's 9, so 9 plus 7 is 16. FD is equal to 24, so this entire length is 24. And E is the midpoint of FD. So if this is the midpoint, then this is length 12, and this is length 12. Okay, so I didn't know it was going to be like that, so sorry. So we know that this is 24, and we also know this one is 16, right, because it's a rectangle. So find the exact perimeter of ACE. So find the perimeter of this triangle. So as I told you, you probably want to know 7, 24, 25. This is why I brought it up, because there's a 25 right here, right? Because this is 7, 24, 25. So that we know that one of the side lengths is 25. This one is 25. Okay, so that's our first side length. We have a 9 and a 12, so Pythagorean Theorem, 9 squared plus 12 squared, that's square root. So 9 squared plus 12 squared. Okay, oops, 9 squared plus 12 squared. And then we square root, which is 15. Which makes sense because this is just a 3. 3 times 3 is 9, and 4 times 3 is 12. So then it's a 3, 4, 5 triangle, so 15 times 3 is 15, right? So the next side length is 15, right? This one. So this is 25, this is 15. Now we need to find this one. So this is 12 and 16. So 12 divided by 4 is 3. 14 divided by 4 is 4. So it's a 3, 4, 5, right? So this is the 3, this is the 4, this is the 5. So you scale by 4. So 5 times 4 is 20. So our perimeter is 25 plus 15 plus 20. So that's 40 and that's 60. So our answer, oops, that looks kind of weird, 60. So our answer for number 11 is 60. Okay, number 12. A rhombus has diagonals of length 18 and 14. Determine the exact perimeter for the rhombus. So a rhombus is like this, where all side lengths are the same. So the diagonal is 18 and 14. So let's say this one's 18. So 18 divided by 2 is 9. 9, right? Because it perfectly bisects it. That's the idea of a rhombus. So if this one's 14, that means this is 7, and this is 7. Okay, so the perimeter is 9 squared. So this is a right triangle, right? So 9 squared plus 7 squared, square root. That's one of the side lengths. So to get the perimeter, you just multiply by 4 because they're all the same. So 9 squared plus 7 squared, 9 times 9 plus 7 times 7. So, and I believe that is cannot be factored. Yep. So that's just 4 square root 130. And that's your answer for number 12. Okay. Number 13. A right circular cone with base diameter 10 and slant height 13 fit exactly in a square prism. So the base of the cone is inscribed in the base of the prism, and both the cone and the prism have the same height. Okay, so we have a cone, and then we have a square prism. So square prism is on that circle, and then you kind of make it like up. So it's kind of hard to draw in 3D, but something like this, right? And then you kind of connect them. That's our square prism. And then you have a cone inside that square prism. So we know our radius is going to be 5 because our diameter is 10. So divide by 2 is 5. And we know our slant height is 13. So this is 13. So this is also like a Pythagorean theorem, that triple that I told you about, which is 5, 12, 13, right? So if this is the 5, that's 13, this is the 12. So the area of our volume of our square prism, we have a base of 5, but the radius is 5. So the entire length is 10. So 10 times 10 is the base times our height, which is 12. So that's 1,200. Now, what's the volume of our cone? It's just 1/3 pi radius squared times height. So 1/3 pi, radius is 5, so 5 squared. Our height is 12. So height divided by 3 is 4, and 25 times 4, because 5 squared is 25, is 100 pi. This is 12. Okay, sorry. So the volume that's inside the prism but outside the cone is 1,200 minus 100 pi, and that is your answer. Sorry that it kind of doesn't look like pies. I kind of just write like 3/4 of that box, but pies are like basically this, if I ever continue writing like that. Okay, number 14. Congruent circles are constructed inside a larger circle. So it's like this diagram. In the center, with the centers of the smaller circles on the diameter of the larger circle. So the two small circles are tangent to each other, and each is tangent to the larger circle. The distance between the center of the smaller circles is 8. Determine the exact numerical area inside the larger circle but exterior to the small circle, right? So the crisscross section, right? So, right? Oops, a little small. Something like this. Okay, so I'm not the best artist. So they say the distance between the two small circles is 8. Since they have the same radius, it's 8 divided by 2, so this is 4. It's 4. So if this is 4, that means this is also 4. So this big radius is 8. So the area of the big circle is pi radius squared, so pi 8 squared, which is 64 pi. And the area of a small circle is 4 pi. It's 4 pi squared, which is 16 pi, right? But there's two of them, so there's 32 pi, right? Because there's two of them, multiplied by 2. So the area that's inside the larger circle but outside the smaller one, so this area, is equal to 64 pi minus 32 pi, which is equal to 32 pi. So that's your answer. Basically just that simple. Okay, question 15. DA and DC are tangent to circle C. Okay, let's kind of draw this out before we do anything. So something here, something here. Actually, let's kind of draw a little bigger so we can see what's happening. Okay, so relatively big enough. There's a line right here. There's a line right here. Okay, I draw that. And that's 90 degrees because that's tangent to it. And we have another line extending out. So there's a point right there. Point here, point here. Right. And they've given us that AB is 60. So this is 60. OA is equal to 4. CF to FD is equal, CF is 3 times FD, so if we call this 3x, right? Because if we call this x, then this is 3x. Okay, so this one's radius. Okay, let's, instead of use x, let's use radius. So if the circle DF is radius r, and this length is 3r, because CF is equal to 3FD. And AED are collinear, CFD are collinear, and BOC is collinear. So they're just saying that they're all straight lines. So find the area of the smaller circle, basically, circle D. So we know that this is 60 degrees, and this makes 180 degrees. And since these two are the same thing, this angle is the same as this angle. So doing that, we could say that this entire thing, 180, is equal to 60 from here, equal to 60 plus that angle plus another angle, which I could just call x, right? So this is 60. So that means x is equal to 160 minus 180 minus 60 is 120. 120 divided by 2 because there's two x's is 60. So each of those angles are 60. So let's kind of delete this. So we know this is 60 and 60. Okay. So this is side length. This is 4 and this is also 4 because they're the same triangle, right? AOD is the same thing as COD. It's the base. It's basically the same thing. Okay. That's just the idea of like of tangencies for triangles like shapes like these. So this is a 4 and this is a 60. Okay. And that's like the 3R, but we don't need that right now. So as I talked about before, this is the 30, 60, 90 triangle. So this is the 30, this is 60. So this is side length x, then opposite of 30 is x over 2. Then opposite of the 60 is x squared 3 over 2, right? So that means opposite of our, this one's the 30, right? Because that's our 60. So right here is 30. So opposite of 30 is x over 2. So this side length right here is square root 3 times that length. So this is 4. So 4 squared 3. Okay. So we know this entire thing is 4 squared 3. Delete. And that's the entire thing. So it's this 3r plus this r right here, the radius of that circle. It's equal to 4 squared 3. So that means 4r is equal to 4 squared 3. That means our radius is equal to square root 3. So the area of our small circle is pi radius squared. So it's pi times square root 3 squared. So that's just 3 pi. Oops, that looks like an n. 3 pi. So our answer for number 15 is 3 pi. And it's basically just that simple. There's just a lot of going on in the picture. That's why it seems kind of difficult. Okay, question 16, parallelogram MET. Okay, so they're just describing the shape over here, so I'm not gonna read the entire thing. So basically, can I draw this out again? So this is 60 degrees, and this is 30, this is 6. Okay, since it's parallelogram, that if this side length is 6, that means the opposite is also 6, so this here is 6. Okay, now let's kind of draw a height here, right? That's our height. So that means if this is 30 degrees, that means this is, I mean, this is 60 degrees to 30 degrees. So this is again a 30, 60, 90 triangle. So 60, 30. So this is side length x. Opposite 60 is square root 3 over 2. Opposite of the 30 is x over 2. So that means we just need to find our height because find the area of a parallelogram is just one of the base because it's both the same thing. If this is 30, this is 30, right? So 30 times the height. So our height is just 6 times square root 3 over 2, which is 3 square root 3. So 3 square root 3 times 30 is 90 square root 3, and that's our area. And that's basically all we had to do. Okay. Number 17. Right triangle ABC with hypotenuse BC has altitude AD and median AE. AB is equal to 6. Okay, so let's kind of like draw that out. So it's a right triangle, so it's right triangle right here because hypotenuse is BC. And then we drew a height, then we made a median. So this length is equal. So this length over here is equal to this length over here. And they said that AB is equal to 6. Okay. And they say BD is equal to 4. Okay, determine the exact length of DE. So we need to find this length right here. So if you kind of ignore the median, let's kind of redraw the picture so we see what's happening. So something like this, right triangle, a right triangle. So I usually refer to this as a right triangle and a right triangle. There's a special property. It doesn't matter which side. If there's a side length right here, let's call this A, let's call this X, and let's call this Y. So the property is that A squared is equal to X times X plus Y. You can find this out using like similar triangles, right? So there's a triangle here, there's a triangle here, and there's a big triangle. You'll find this out, but this is gonna be true. So using this idea, that means 6 squared is equal to 4 times, okay, let's call this entire thing X, and equal 4 plus X. So 36, so 6 squared is 36. 36 divided by 4 is 9. So 9 is equal to 4 plus X. That means X is equal to 5. So we know this entire length is 5. Okay, so let's kind of erase that. So we know this is 5. Okay, so now we just need to find out what this length is, which is we could use the same thing. So we could call this X now. So X squared is equal to now 5, because that's the length under it, times 5 plus 4, which is 9. So X is equal to the square root of this entire thing, right? Which is equal to 3 square root 5, because only 9 could be square rooted. So X is 3 square root 5. Oops, delete. Equal to 3 square root 5. And this is our 5. This entire length is 5. So if we know, we could use this triangle over here, right? A length, DE. Oh, right, yeah, DE. So actually, we don't need it. So another property that you could use for right triangles, let's call this H, is H squared is equal to the, wherever you cut off, right? You have a right triangle and another right triangle. And we'll call this H, and we say from here to here is X, and from here to here is Y. H squared is equal to X times Y. Okay, so that's another property. So that means H squared is equal to 4 times 5. So H squared is equal to 20. So H squared is 2 squared 5. I mean, H is equal to 2 squared 5. So this length is 2 square root 5. Okay. So we know that these are true. So we just need to find this length because we know this is the median, right? So it cuts this in half. So actually, you actually didn't need to find this. Doesn't matter because we know that this entire length is 9, right? So median, we know that this length is equal to this length, right? So that is going to be a 4.5 because 9 divided by 2 is 4.5. So from here to here, that's 4.5, and this is 4.5. But this entire thing over here is 5, and we just need to find this length. So that length is just 5 minus 4.5, which equals a half. So that's our answer for number 17, 1/2. That's it. But it's a pretty interesting question with a bunch of properties that's pretty interesting, pretty cool to learn. Number 18. The measure of two angles of a triangle are in the ratio 2/3. The third angle measures 4 degrees more than the larger of the two angles. So let's kind of make this. So the ratio of two angles is 2x to 3x, right? So the third angle is 4 degrees more than the larger of the two angles. So the larger one is 3x, so plus 4. So determine the degree measure of the exterior angle adjacent to the third angle of this triangle. So it is adjacent to this one. Okay, so we need to find this angle right here. So let's find out what x is. So 3x plus 2x plus 3x, that's 8x, plus 4 is equal to 180. So 8x is equal to 176. So x is equal to 2, that's 16, so 22, right? So x is equal to 22. So the exterior is always going to be the sum of the two other angles, not the one next to it, right? So it's going to be 3x plus 2x with this 5x. So what is 5x? Well, 5 times 22, that is 110. So the exterior angle to the third angle is equal to 110. And that is your answer. Okay, pretty simple. Number 19. Square ABCD has E at the midpoint of AB. So let's kind of draw that out. So ABCD. And E is the midpoint of AB. So E, this is equal to this. And EB is extended beyond EB is extended beyond B, and point F is positioned on ray EB such that EF is equal to EC. So this EC, this length is right over here. EF is equal to EC. Okay, something like that. Well, it's a little shorter. So something like right here. F, right? So DC is extended past point C, and point G is positioned on DC such that EF is equal, oh, sorry, so that CGF is a right triangle, right? So CGF. So we have a G right here. And that's going to be a right triangle. Okay. And the ratio of FG to DG can be written as K plus W squared P is equal to Q. Okay. So let's kind of find out what that is. So let's first find out what FG is. FG is just gonna be X, right? Because if we call this X, the side length of a square is X, then FG is gonna be X. Okay, over DG. So we need to find out DG. So DC is X, so we could just call that X. So we need to find CG. So what is that length? So we know CG is equal to BF. So we need to find out what BF is. So we know that EF is equal to this length, which is just a half and a half. So x, 1/2 of x, and this is x, this 1/2 of x. So the hypotenuse is just 1/2 squared plus x squared, square root, right? So I'm going to clean this up so it looks a little nicer. Okay, so 1/2 x squared plus x squared, square root. So that's 1/4 x squared. This is just x squared, so that's 5/4 x squared. So that's just 1/2. So that's x over 2 squared 5. So that's that length. And since this is x over 2, we got minus x over 2. And that gets just BF, which is equal to CG. So we just need to add that in. So x over 2 squared 5 minus 1/2. Okay, so now we just need to simplify this. So delete, delete. And let's move this over. Oops. Okay, so we could take out the away the x's. So x divided by x is 1. X divided by x is 1. This x is just 1/2 squared 5. Oops, it looks kind of bad. Okay. And let's kind of extend this out because I'm running out of room. Minus 1/2. Okay. So this is 1 over 1 minus this 1/2 is 1/2 plus 1/2 squared 5. So multiply the top and bottom by 2. So this becomes 1 plus square root 5. Okay. So 2 over 1 plus square root 5. Now we got to multiply this by negative 1 plus square root 5. Negative 1 plus square root 5, right? We want to rationalize the denominator. So negative 2 plus 2 square root 5. So that is negative 1 plus square root 5 minus square root 5. So this cancels out and then plus 5. So this simplifies to it's just a 4. So then we could divide 2 in the top and bottom, which gets negative 1 plus square root 5 over 2. So that is, so our k is negative 1, our w is 1, our p is 5, and our q is 2. So adding them all up together, we get a 7. That's 19. And that's basically it. Just draw a picture and keep track of everything, and you should get it right. Number 20. Three congruent circles with radius 4 are pairwise tangent. Determine the area enclosed by the three circles, right? So we have three circles. So something this. Okay, that's kind of bad. Yeah, something like this. And then you want to find the area in here. Okay. So what we're going to do is that we're going to put the centers, and then I'm going to connect them. Okay. So since they all are the same radius, right? Three congruent circles, so they're all the same. That means if this is R, 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 this is R. So this length is 2R, this length is 2R, this length is 2R. So this tells us that this triangle is a equilateral. So it's 60 degrees. Okay. And they also have radius 4. So this is 4 and this is 4. So our side length is 8. So if this is so to find the area, let's just kind of like what's the area of a equilateral triangle? An area of equilateral triangle is x squared squared 3 divided by 4, where x is the side length. So our side length is 8, so it's 8 squared squared 3 divided by 4. So 8 divided by 4 is 2. 2 times that 8 is 16, so this 16 squared 3. So area of our triangle is 16 squared 3. Now we just need to take away the like sections of those circles, right? So 1/6, so 60 is 1/6 of 360 of the entire circle. So it's 1/6 of the circle, of the area of a circle. So 1/6 pi radius squared. So our radius is 4, so 1/6 pi 4 squared. So there's 1, 2, 3 sections because they're all the same. So we can just multiply by 3. So we multiply this by 3. So that's just 1/6 times 3, that's 1/2 pi 4 squared. So 4 divided by 2 is 2. 2 times that other 4 is 8, so that's 8 pi. Okay, so that's the area of those sections of circles. Now we just need to subtract them to get the area inside. Oops. Okay, so 16 square root 3 minus 8 pi. So they don't want the exact area. They just want to find the area rounded to 4 significant figures. So 16 square root 3 minus 8 pi. That should get you about 2.580. You have to write the 0 in here because it's 4 significant figures. You have to write that 0. So you have to write 4 digits. So that's basically everything. So review, you might want to know the area of a equilateral triangle, which is x squared, x, which is side length squared times square root 3 over 4. 19 is just kind of weird, but that's basically it. Um, 15 is kind of weird, I guess, but it's kind of like 19. 17, you might want to learn like how the properties between a right circle inside of a like a right triangle, which I could just say right now. So you have like a right triangle, okay, and that's a right triangle. This is a right triangle. That's a H, and I'll call this A, and I call this B, call this X, and let's call this Y. So A squared is equal to X times X plus Y. B squared is equal to Y times X plus Y. And H squared is equal to X times Y. Sorry about that. So these things are always true. These are the three properties. But A squared and B squared are basically the same. It's just which side length is under it. Okay. So other than that, everything is kind of basically pretty simple. Like the first 10 are pretty okay. And that's basically it. Well, thanks for watching, and I'll see you at the next math record.